Okay, good morning. So we're going to continue where we left off with static electricity, and let's uh, let's we're going to continue with question 7. All right. So we did the first part question. We did question 7A. So let's move on now to question 7B. So question 7 says complete the following statements. So after some rather exhausting counting, okay, a physics teacher determined that a very small sample of an object contains, 7b is, it contains 3.12 times 10 to the power 14 protons, that's a number of protons, and 4.5488 times 10 to the power 16 electrons, and they want you to find the charge on this object. So we have to find just looking at the question, there is an excess of electrons. There is an excess of electrons, so we have to find out how much more excess electrons there is. So what we're going to do, all right, so to find the excess of electrons, so we have to subtract from this. Remember that electrons are negatively charged and protons are positively charged. So you always have to remember that. So the excess of electrons, so call it EE, excess of electrons. So excess of electrons, EE, is equal to 4.5 4.5488 times 10 to the power 16, and from that 10 to the power 16. From that you're going to subtract the number of protons. Okay, the number of protons is 3.12 times 10 to the power 14. All right, you can just, they should have times 10 to the power 14. For uniformity, let's put a multiplication sign right here. All right, so essentially we have to simplify this. Okay, so we're subtracting this quantity from that quantity. So if we make the power of 10 the same, so to get 10 to the power 14 to 10 to the power 16, we're going to have to move the decimal point 2 places to the left. So this would be 0.03. So it will be 4.54 88 488 88. Okay, you're going to subtract from that. So put this in bracket to neaten up our equation. So from that you're going to subtract 0. So if we move the decimal place 2 points to the left, 1, 2, we get 0.03. 0.03. and then outside the brackets is 10 to the power 16. All right, that's times 10 to the power 16, because we converted this 10 to the power 14 to 10 to the power 16. So we'll be left with, so excess electrons, okay, so it would be 4.5, let's put our point, 4.5 1, because we're minus the 0.03, 1, 8, 8 times 10 to the power 16. So this is the excess amount of electrons that we have. So this is a negatively charged object, okay? So it's a negatively charged object, and it's, so you can put the minus sign there to denote negativities. This is the amount of excess electrons. Remember, the amount of charge on an electron, let's put that over here. So the amount of charge on an electron, so look, put EC for that, electron charge. So the amount of charge on each electron is 1.6 times 10 to the minus 19 coulombs. Remember, 1 coulomb is a very large number. This is the charge on just one electron. Okay, 10 times 10 to the minus 19. Charge on a single electron. So this is in coulombs. So if you have this many electrons, the overall charge, so the charge on the object, put OC for that. The charge on the object, the overall charge on the object, is equal to the number of electrons times the charge on each electron. So this would be 4.518 times 10 to the power 16 times the charge on each electron, which is 1.6 times 10 to the power minus 19. So we're going to multiply these two numbers, 10 to the power minus 19. So the charge, the overall charge is 4.5188 times 1.6, and let's do the math for that. So the charge, so we get 4.5188 times 1.6, and that is equal to 7.23. So this is, okay, this pen is all over the place. So that's 7.23008. So that is the 4.5188 times the 1.6. And then when we multiply or 10 to the powers, we have to add the numbers. So that is times 10 to the, so you have a plus 16 minus 19, that's a minus 3. So minus 3. Okay? And this is in coulombs. So the overall charge is in coulombs. Okay? So this is the overall charge. So we're not going to do the others because it's the same process. You have to find the excess electrons or protons, and then from once you find the excess protons or electrons, you multiply the excess protons or electrons by the charge on each electron. Remember, electrons are negative, and then protons are positive. If you have excess protons, it means that the object is deficient in that amount of electrons. So that's why it's positive. So the exercise is the same for all of them. It's an exercise in multiplying these powers and manipulating the powers, but the concept is the same. So let's all right, so let's move on now. All right, let's look at question 8. The amount of charge carried by a lightning bolt. The amount of charge carried by a lightning bolt is estimated at 10 coulombs. What quantity of excess electrons is carried by the lightning bolt? All right, so remember, a coulomb is a very large number. So what quantity of excess electrons is carried by the lightning bolt? Remember, at the first session, we said that 1 coulomb, or let's say minus 1 coulomb, so minus 1 coulomb is equal to an excess of electrons in the amount of 6.25 times 10 to the power 18 electrons. So if an object has a charge of minus 1 coulomb, it means it have an excess charge of it means that an excess amount of electrons of 6.25 10 to the power 18. Again, if an object has a charge of minus 1 coulomb, it has an excess of electrons in the amount of 6.25 times 10 to the power 18. That is the amount of excess electrons. If an object has a charge of plus 1 coulomb, it has a deficiency in electron of the order of 6.25 10 to the power 18, or an excess of protons in that same amount. So a lightning bolt is an excess of electrons. If the lightning bolt is estimated at a coulomb of 10 coulombs, then what's the quantity of excess electrons there is? Again, 1 coulomb have this amount of 1 coulomb of this amount of electrons. So minus 1 coulomb of this amount of electrons. So what is the quantity of excess electron carried by the lightning bolt? So 10 coulomb is going to have 10 times this number. Okay? Because 1 coulomb contains 6.25. So minus 1 coulomb has 6.25 10 to the power 18 electrons. So 10 coulomb is going to be 10 times that amount. So 10 coulombs have this many electrons. Say it's 6.25 times 10 to the power 18 times 10. For 6.25 times 10 to the power 19. So that's the number of excess electrons. Okay. All right. So I think that one was straightforward. Let's look at question 9. So question 9 reads, respond to the following student statement. A positively charged object is an object that has an excess of positive electrons. So from the basic understanding of static, or the basic understanding of atoms, we know that the atoms have a densely packed nucleus which contains protons, which are positively charged, neutrons, which are neutral, and electron shells, which contains electrons, which are negatively charged. So electrons are negatively charged. They're always negatively charged. An object that is positively charged is going to have a deficiency in electrons. Again, remember that electrons, for our purpose of static electricity, electrons are the only thing that can be removed. So if you have a negatively charged object, that means it gained electron from somewhere. And if you have a positively charged object, that means the object loses some of its electrons. So it loses its neutrality, so it becomes positively charged. Okay. So that's basic. So to calculate the charge or the number of electrons, the numbers you have to remember is that the charge on each electron is 1.6 times 10 to the power minus 19 coulombs. Okay, so the charge on each electron is 1.6 times 10 to the power minus 19 coulombs. And when we say an object has a charge of minus 1 coulomb, that object has an excess amount of electrons in the order of 6.25 times 10 to the power 18. So those are the numbers you have to remember. And then the other aspect of that is just doing some basic math. All right, so what about electric force? So there is a force between charged objects and even non-charged and non-charged objects. It's a non-contact force. Remember when we did forces, we talk about contact force. You know, you're pushing on something, you're pulling on something. So contact forces. Now, electric force is a non-contact force because you don't have to come in contact with an object in order to experience that electric force. And the electric force can be attractive or repulsive, okay, depending on the charge of the objects that come in contact with each other. And we'll go over that. Again, if you remember, like charges is gonna repel. So a positive and a positive is gonna repel. A negative and a negative is gonna repel. However, charged objects and neutral objects or uncharged objects are gonna attract. So the important point, electric force are non-contact force. Electric force is non-contact force. You don't have to have any contact between the objects. The force can be attractive, that means they pull towards each other, or they can be repulsive, they push away each other. Like charges, that is, if you have a positive and a positive, it's going to repel. Negative and a negative, going to repel. However, opposite charges, positive and negative, will attract. Or charged forces, such as positive or negative, with an uncharged object, is going to attract that uncharged object. So this is essentially what it looks like. So you can see a positively charged object and another positively charged object, they repel each other, so they're pushed away. And we use balloons because balloons demonstrate this very, very well. If you have charged balloons, you can see this effect. However, if you have a positive balloon and a negative balloon, the opposite charge, they're going to attract each other. And you can suspend balloon in the ceiling close to each other, and you can run these experiments by yourself. Okay? So we're going to, talk about the law of static electricity. Basically the same thing that I've been going over. So if you have a positive charge and another positive charge, they're going to repel each other. Like charges repel. A negative charge and another negative charge, they're going to repel each other. That's the electric force. There's going to be a force pushing them away. However, if you have opposite charge, a negative and a positive, they're going to be this attractive force. They're going to be pulled towards each other. And then in the third scenario, if you have a positively charged object, say it's negative, and a neutral object or a non-charged object, it's attractive. So always a neutral object is attracted to a charged object, whether it's negative or positive. And that's a very important point to carry home, okay? Neutral objects are attracted to charged objects. All right. So as we said before, your electric force is a non-contact force. You don't need that contact between the objects to experience the force. And the force can be attractive, pulling towards each other, or it can be repulsive, pushing away. You can create a charged object by rubbing, and we use balloon a lot to do in these experiments, because you can charge a balloon by rubbing the balloon with animal fur or a wool sweater, and you can charge the balloon up. And you can do this experiment at home. So when you charge a balloon up and you bring the balloon in contact in close distance to a small bit of paper in its vicinity, if the balloon is gonna attract the paper, you can see the balloon lifting the paper off the ground. The paper is neutral, the paper is neutral, the paper is not charged, but the balloon is charged. And remember what we said, a charged object is always going to attract a neutral object. A charged object, whether positive or negative, is always going to attract a neutral object. So you can do this experiment. Put a charge in the balloon by rubbing it with an animal fur or wool sweater, fairly close proximity to a bit of paper, small piece of paper. You'll see that it's attracting the paper. Again, opposite attract, call that attractive force, and like repel, repulsive force. And these forces are electric force. Again, when we charge a balloon up, the balloon usually is negatively charged. So when we use our fur or wool, we transfer electrons to the balloon surface, and the balloon becomes negatively charged. And then the wool, because the wool loses electron to the balloon, the wool is now positively charged. Okay, so that's what you're doing. You remember, the only thing that you can move is electrons. So when you rub that wool on the surface of the balloon, you're going to transfer electrons to the balloon surface, and the electrons came from the wool, so the wool is going to be deficient in electrons, so it's going to be positively charged. So again, you're doing your experiment. You suspend these balloons from the ceiling, and because they're positively charged, you're going to see the balloons pushing each other away. So when you look at the balloon in this suspended on the ceiling, they're going to be apart. They're not going to be vertically downward. You're going to see that they are spread apart because of this electric force. Like charges is going to repel. So the balloons are not going to be vertical. They're going to spread apart. So once we talk about force, any kind of force, Newton's third law or Newton laws apply. Remember what Newton's third law said, that force comes in pair. Okay, there's a equal and opposite reaction. So it's an action-reaction force. So if you have, say, if you have two charged objects, say that they're similarly charged, they're going to repel. So one is going to push off the other, and the other is going to push off the other object. So the forces are going to be in the opposite direction, but the same magnitude. So the electric force is going to be opposite, since the objects are pushing each other away. The magnitude of the force is going to be similar, but the direction of the force is going to be opposite. If the charges were opposite, positive and negative, you're going to have an attraction. Each of the object is going to pull and the other. Same amount, but in the opposite direction. So the forces are equal in magnitude, but opposite in direction. Newton's third law. This just shows you that you can, and this is what static electricity looks like. It is the force that exists between charged objects, and so one of these object have to be negative and the other object positive, and then you have your electric force. And similarly, especially during the winter months, we can, we get shocks, electric shocks all the time, touching doorknobs, and we can have these type of hair day where the hair is on hand. And when we delve a little bit more into static electricity, we'll explain exactly why this occurs. So this is not magic, it's just static electricity. So what is static electricity? We have shown you how we can develop charge on objects, and we talk about electric force. But what is static electricity? So basically, even though we create charges on objects, the charges are not moving. The charge are stationary. So when we put a negative charge on the balloon, these electrons are on the surface of the balloon and they're not moving. And that distinguishes static electricity from regular electricity, where you have a movement of electrons. Okay? In static electricity, the electrons do not move. Okay? They build up on the surface of the material, the balloon or whatever, okay? But the charge, the charge, the charges do not move. They're just on the surface. They're gonna exhibit an electric force, but the charges do not move. All right, so you can create, or you can create a negative charge by, you know, moving electrons from an object to another object. And we know that wood attract some electrons, so you can create a negative charge on the wood. Nickel, copper, you can commonly create negative charge by transferring electrons. Gold, platinum, similarly, you can create a positively charged object by removing the electrons from the object. So to create a positive charge, so you can do that using dry human skin, leather, and glass. Okay. Some of the uses for static electricity. So this is not only for experiment and to talk about. We use static electricity in photocopying, printing, spray painting, and pollutant removal. So, you know, it has practical applicability. All right. So when the electric force, as we had mentioned before, is either attractive or repulsive. Attractive if we have opposite, positive and negative, or if we have charge and a neutral. Charged objects and neutral objects exhibit an attractive force. Positively charged objects and neutral objects attract each other. Negatively charged objects and neutral objects attract each other. So charged and uncharged attract each other. All right, so we're going to do some questions so that we have a much better understanding of what we just discussed. So use your understanding of charge to answer the following questions. So electric forces, so which one is the correct? Electric forces can cause objects to attract each other. Can cause objects to only attract each other. Not really. Can cause objects to only repel each other. Not really. Can cause objects to attract or repel each other. That is true. And can have no effects on objects. So remember, if you have two opposite charge objects, they're going to attract each other. If you have a charged object and a neutral object, it's going to attract each other. And if you have like charges, they're going to repel. They're going to repel. So answer C is the most correct. Can cause objects to attract or repel each other. We will explain further why charged and neutral objects attract each other. There's an explanation for that, but we'll get there. All right. So question 2. Question 2. On 2 occasions, the following charge interaction between balloon A, B, and C are observed. In each case, it is known that balloon B is charged negatively. So balloon B is charged negatively. Based on these observations, what can you conclusively confirm about the charge on A and C for each situation? So let's look in case 1 then. So we know that B is negative. So what can we say about A? When we look, A is attracted to B. So if B is negative, then A could be positive or A could be neutral, because remember that charge attracts neutral. But when we look at B and C, so B and C, so B B and C repels each other. B and C repels each other. Okay? So we know that B is negative, and the only way B and C is going to repel, they have to be like charges. It has to be like charges. So C have to be the same charge as B. So C has to be negative because it repels B. Okay? And as we say that A and B attracts each other, A and B attracts each other, and we know that B is negative. B being negative can attract a positive and it can attract a neutral. So A is either positive or neutral, and C is definitely negative. All right, let's look at case 2. In case 2, B is still negative. So, and A is attracted to B. So if A is attracted to B, B being negative, so A could be positive or it could be neutral. Okay? All right. In the second scenario, A and C repels each other. A and C repels each other. So for C to repel A, it has to have like charge, similar charge. C has to have similar charge as A. But we know that A only have positive or neutral. A is either positive or neutral. So C cannot be neutral because neutral objects do not repel anything. Neutral objects always attract. So C have to be positive. That's the only way it's going to repel A. Okay? So C has to be positive. Okay? And what we know is that A cannot be neutral because neutral objects never repel anything. So A has to be positive and C has to be positive. Okay? So you just have to look at the scenario and work it out. All right, let's look at question 3. Upon entering the room, you observed 2 balloons suspended from the ceiling. You notice that instead of hanging straight down vertically, the balloons seem to be repelling each other. And you can conclusively say, so again, experiment you can do at home, create a charge in the balloon by rubbing the balloon with wool or animal fur. You're going to get a negatively charged balloon because you're going to transfer electrons to the balloon surface. And you can also create a positive environment as well. But in this experiment, we don't know the charge. We just know that these 2 balloons repel each other. What can you say conclusively? Okay? Both balloons are negatively charged. We don't know that. Both balloons are positive. We don't know. It could be. It could be. One balloon is charged positive and the other is negative. Definitely. Because the balloons have to have the balloons cannot have opposite charge because we know that opposite charge is going to attract. So the balloons have to have the same charge. Okay, both balloons are charged with the same type of charge. Yeah, we don't know the nature of the charge, whether it's positive or negative. But what we know, for them to repel, they have to have the same charge, a like charge. Okay, if they had opposite charge, they would attract each other. Okay, all right. Let's look at question 4. So question 4, Genius is investigating the charge on several objects and makes the following findings. So you have object C, object D, object E, and object F. So object C attracts object B. object D repels object C. Object E attracts D and F, and object F attracts A. What they want you to do is, well, G knows that object A is negatively charged and object B is electrically neutral. So A is negative, so A is negative and B is neutral. What can genius definitively conclude about the charge on C, D, E, and F, and explain? All right, so so object A is negatively charged. We know that for sure. A is negatively charged and B is neutral. Okay? All right. So object C attracts B. B is neutral. So what can we say about object C? So if object C is attracting B, so B is neutral, right? B is neutral. A neutral object will attract any charged object. So what we can say about C, C can be positive or it can be negative. C can be positive or negative since it's attracting a neutral object. Another neutral object will not attract another neutral object. So we can say that C is positive or negative. Let's see. Okay. C repels D. C repels D. A neutral object will never repel another any object. A neutral object will never repel any object. So C is not neutral. Okay, C is not neutral. Okay, all right. Okay, let's look at let's look at D. All right, let's look at D. So D is attracted to E. So we don't know what's going on, but D is attracted to E. Okay, and we know that E repels F. E repels F. So if E repels F, so we know that E cannot be neutral. E cannot be neutral since it repels. Okay, so E is definitely going to be charged. Okay, and since E is charged, it could be positive or negative since it's charged. Okay, let's look at F. F attracts A. We know that A is negatively charged. So if F is going to attract A, so it's F is either positive or neutral. Since F is attracting A, it can only be positive or neutral. Okay, so let's put it down. So F is positive or neutral. Okay, but you can see that F repels E. A neutral object is not going to repel anything. So F can only be positive. Okay, so F can only be positive. All right. So, and if F, so F will attract A because A is negative, F is positive. F can, so F is going to repel, so we say that F is positive. So if F repels E, it can only repel E if E is of same charge. It cannot be neutral. So E have to be positive, because only like charge is going to repel. We said that F is positive, so E has to be positive. Okay? Now, so we know that E is positive, and D attracts E. So if E is positive, so D could be neutral or negative to attract E, since E is positive. But D is repelling C. A neutral object will never repel anything. So what we're saying, E is positive, so D could be, as we said, D could be neutral or negative. Okay? But because D repels C, it cannot be neutral. So D has to be negative. Okay? And so D has to be negative. And because D repels C, then C have to be positive. Sorry, C has to be negative as well. Okay? Okay, C has to be negative. So C is negative. So a negative charge is gonna attract a neutral charge. D is negative, and because C is negative, they're gonna repel each other. E is positive, and we said that F is positive, so they're gonna repel each other. And D is negative, so the positive and negative is gonna attract. And we said that F was positive, and because A is negative, they attract each other. So you just have to work it out. All right, so let's look at this question. Two objects are charged at the right. Object X will be and object Y will be. So you can see that object X is positively charged, Y is positively charged. So they're going to repel each other because they're like charge. They're going to repel. And then two objects are shown on the right. One is neutral and the other is negative. So a charged object and a neutral object will attract. All right. Question 8. You have balloon X, Y, and Z are suspended from the ceiling as shown. Negative charge on balloon X attracts balloon Y, and Y attracts balloon Z. So Z is what charge? Okay, so you can just write it down. X is, so these are balloons. X is negatively charged, and it attracts Y. So Y is either positive or neutral, because X is negative. So Y can only be positive or neutral. But Y attracts Z. So if Y attracts Z, then Z may be okay. So we said that Y is attracted to X. X is negatively charged. So Y is either positive or neutral. Okay, positive or neutral. But Y is attracted to Z. The only thing we can say about Z is that Z may be negative, because if it's negative and Y is neutral, then it will be attracted. Or Z could be positive, and if Y is neutral, it will be attracted. Z may be neutral, because if Y is positive and If Y is positive and Z is neutral, they'll be attracted to each other. So what you can say is that maybe Z is charged. It may be charged. Z may be maybe positively charged. It may be negatively charged, or it may be neutral. So Z can have a negative, a positive, or a neutral. Okay, because we know that like charges is going to repel. Neutral charges never repel anything. So if X is negative and it attracts Y, if X is negative and attract Y, then Y could be neutral or it could be positive. Okay, we don't know for sure. It is attracted. Y is attracted to Z. So if Z is positive, then if Y is positive, then Z could be negative or it could be neutral. But if Y is neutral, then Z could also be negative. So you just have to sit down and work out the scenario and see. All right, so what we're going to do, we're going to stop here, and our next session, we will go a little bit further into the concept of static electricity.